In July 1994, every telescope on Earth and in orbit pointed at Jupiter, and what they watched happen over 6 days was something no scientist had ever observed in real time: a comet being torn apart by gravity and then crashing piece by piece into the largest planet in the solar system. 21 fragments, 21 impacts, and scars left in Jupiter's atmosphere the size of Earth. Comet Shoemaker-Levy 9 was discovered on March 24, 1993, by astronomers Carolyn and Jean Shoemaker and David Levy, using photographic plates taken at Palomar Observatory. The images showed something immediately unusual. The comet appeared as a chain of objects rather than a single nucleus, elongated, strung out like pearls on a string. It had already been captured by Jupiter's gravity and had passed so close in July 1992 that tidal forces pulled it apart. The Roche limit, the distance at which a body's self-gravity can no longer resist tidal disruption, had done its work. What had been one comet was now a chain of at least 21 identified fragments, some estimated to be several hundred meters to over a kilometer in diameter. Orbital calculations immediately revealed something extraordinary and alarming. The fragments were on a collision course with Jupiter, not a near miss. A direct impact, scheduled for July 1994. Scientists had never observed a major cometary impact on a planet in real time. For the first time in history, astronomers knew exactly when and where a collision would happen. From July 16 to July 22, 1994, the fragments designated A through W struck Jupiter's southern hemisphere in sequence. The impacts occurred just past the limb of Jupiter as seen from Earth, meaning the direct flashes were not always visible, but the rising fireballs and their aftermath were directly observed by the Hubble Space Telescope, the Galileo spacecraft en route to Jupiter, and hundreds of ground-based observatories worldwide. The energy releases were staggering. The largest impact, Fragment G, which struck on July 18th, released energy estimated at approximately 6 million megatons of TNT. To put that in context, the most powerful nuclear weapon ever detonated, the Soviet Tsar Bomba, in 1961, released 50 megatons. Fragment G's impact was roughly 120,000 times more energetic. The fireball it produced rose thousands of kilometers above Jupiter's cloud tops, briefly glowing hotter than the sun's surface. Each impact left a dark scar, a region of chemically altered atmosphere visible as a dark spot against Jupiter's cloud bands. The largest scars were significantly wider than Earth's diameter. They remained visible for weeks. The dark material was a combination of disrupted atmospheric chemistry and material from the comet itself, including carbon, sulfur, and silicate compounds that had no business being in Jupiter's upper atmosphere, but now were. The aftermath revealed something important about Jupiter's atmospheric chemistry and structure. Spectroscopic observations detected water, sulfur compounds, and heavy molecules in the impact plumes, confirming that the energy of the impacts had excavated material from depths below the visible cloud tops. This gave scientists a rare window into Jupiter's chemistry at levels that could not be probed by normal observation. The scientific consequences extended beyond Jupiter. Shoemaker-Levy 9 demonstrated that major impacts are not events confined to the ancient solar system. They happen in the present era. It reinforced the importance of planetary defense, the systematic search for near-Earth objects that could pose a similar threat. NASA's current Planetary Defense Coordination Office traces much of its institutional momentum to the public attention generated by the 1994 impacts. The Galileo spacecraft, the only probe positioned to observe the impact sides directly, captured data confirming the energy estimates and revealing the detailed temporal structure of the impact events: the entry fireball, the bounce wave, and the rising plume in sequence. 3 decades later, Jupiter is understood to serve as a gravitational shield for the inner solar system, capturing or deflecting comets and asteroids that might otherwise reach Earth. Shoemaker-Levy 9 made that protective function dramatically visible. Follow for more on the events that changed how science thinks about planetary defense and solar system dynamics. And tell me, watching Jupiter absorb 21 comet impacts in 6 days, does that make you feel more protected knowing Jupiter is out there, or more aware of what could happen if one of those fragments had been aimed at Earth?